Loops are code structures designed to run the same code any given number of times. The four most common loop structures are while, do, for each, and for. We looked at the structure of an if statement in a previous video, and it looks like this. The while loop is nearly identical in structure. It looks like this. When execution reaches line 1 above, it evaluates the Boolean statement. If the Boolean is true, it executes all the code between the braces. After that code runs, and execution reaches line 4, execution goes back to line 1, evaluates the Boolean again. And execution will continue to loop until the Boolean evaluates to false. The do loop is almost the same. It looks like this. It's nearly the same type of loop, but with one major difference. The Boolean is considered at the end of each execution instead of the beginning. The for each loop is a little different. We haven't talked about collections yet, but in code, collections are what they sound like, collections of things such as variables. The for each loop lets you run some code once for each item in a collection. The basic format is like this. We read that as do something for each item in the collection. As a real example, let's say I had a collection variable called task estimates filled with integers, and I wanted to sum all of the integers in the collection. The for each loop might look like this. For each estimate in task estimates, add that value to total estimates. The last loop type is the for loop. Before we look at that, let's say we wanted to run a loop for only a certain number of times, which seems like a common thing a programmer might want to do. Say we want to loop 10 times. Well, we need a variable to keep track of how many times we've run through the loop. We could do that with a while loop. So we declare an integer variable, set I equals to 0, and then our while loop will say while I is less than 10. Inside the loop we do some work, then we do I++, which increases the value of I by 1. This loop will then exit as soon as I has been incremented 10 times. That'll do the job. However, the for loop was invented for exactly this purpose. Here's what the same code would look like as a for loop. This code executes in a specific order. The variable I is declared as an integer and assigned the value 0, which you can assign any value here, but it's usually at 0. This piece only executes one time in the beginning. Second, the Boolean is checked, which is the question, is the value of I less than 10? If no, exit the loop. If yes, proceed to 3. 3 is enter the for block, execute any code. And fourth, I will increment by 1, which is the piece of code that says I++. And fifth, we'll go to line 2 again, which is to check the Boolean statement. If it's still true, it re-enters the loop. If not, it exits. There are 2 additional features that all of these loops share. They're for dealing with 2 specific scenarios. The continue keyword is for when you want to move to the next item in a loop without running all of the code below. And 2 is the break keyword, which is for when you want to stop the loop without finishing the rest of the items. 2 quick examples. Let's look again at the loop which totaled estimates. Maybe sometimes there are negative numbers in the estimates which mess up the totals, so we can use continue to skip over those items as follows. So for each estimate in task estimates, if the estimate is less than 0, continue, which goes to the next item. If not, then add it to our total estimates. Let's say we also don't accept estimates greater than 100. If we hit 100, we just want to stop adding. We can use the break keyword as follows. Now, if total estimates is 100 or greater, the if check on line 8 succeeds, break gets called on line 10, and the code exits the loop prematurely. Jumps us to line 13. So in summary, we have 4 main loop types: while, do, for each, and for. and 2 helper keywords for working with loops, continue and break. Now, let's use our loop to solve the problem we have in our to-do app.